Hi students, today I have come up with one more interesting topic from the gaseous state, how to solve the density related problems. So we'll start the topic by solving the problem itself. And now the problem is, at a fixed temperature and 600 mm pressure, the density of a gas is 42. At the same temperature and 700 mm pressure, what is the density of the gas? So here at a fixed temperature means first you have to recollect it is a Boyle's law. So when the temperature is constant, what is Boyle's law? Here when the temperature is constant, what are the variables? Pressure and volume are the variables. So here instead of the volume in the problem, pressure and density are given. So first you recollect what is Boyle's law. What is Boyle's law? Here at a constant temperature, here temperature is constant, it is constant. At a constant temperature, pressure is inversely proportional to volume. At a constant temperature, pressure is inversely proportional to volume for a given amount of a gas. That is Boyle's law. Now here, what is density? Density is equal to mass by volume. Density is equal to mass by volume. Now from this density D, we can write density D is inversely proportional to volume. So if you observe this and this, pressure is inversely proportional to volume and the density is inversely proportional to volume. So how these two are related? Can I write like this? Pressure is directly proportional to density. Okay, now this proportionality is replaced by a constant K, and here what we can write, and the relation is P1 by D1 is equal to P2 by D2. Now you got the formula for this problem. So here what is the formula? That is P1 by D1 is equal to P2 by D2. Now what is the data given? Look at the problem. At a fixed temperature, it is your P1, and density of the gas, it is D1. At the same temperature, 700 mm, it is your P2, and asked you to find out the density of the gas, means here D2 you have to find out. So substitute the values. What is your P1? It is 600. What is your this one? Density 42. And next P2, it is 700. And D2 you have to find out. So it is, what is the value of D2? By solving this you will get the value of D2 density. That will come 49. 49 will be your answer. So here I think you got one clear idea how to solve this type of problems when Boyle's law in relation with density. So here what is Boyle's law? At a constant temperature for a given amount of a gas, pressure is inversely proportional to volume, and density mass by volume. And here these two are related like this. Pressure is directly proportional to density. From this relation we have derived P1 by D1 is equal to P2 by D2. By using this formula you can solve when pressure and density, you can solve the problem when pressure and density are given. Okay. Now we'll solve another problem related to density. This is also from the gaseous state. So what is the density of 1 mole of helium, and the molar mass of helium is given, that is 4 grams per mole, and at 300 Kelvin a temperature has given, and a pressure of 0.82 atmosphere pressure is given, and R is universal gas constant. And here if you observe the data, here 1 mole means here it is N, and also it is T, temperature T, and it is P, and it is R. Here it is a ideal gas equation, the data, and here if you observe the data, this density in relation with ideal gas equation. So here what is ideal gas equation? That is PV is equal to nRT. What are the terms in this ideal gas equation? P is pressure, V is volume, N is equal to number of moles, and R is universal gas constant, and T is absolute temperature. And here what is N? Number of moles. What is the formula for number of moles? Number of moles is equal to weight by molecular weight. Weight upon molecular weight, it is the formula for number of moles. And here it is an ideal gas equation. Here what is the question? What is the density? Density from the ideal gas equation. So if you substitute this, PV is equal to weight by molecular weight RT. This molecular weight you can represent with a capital M, that is your convenience. Now here what is the density? In the previous problem also I have told you, density is mass by volume. What is density? Density is equal to mass by volume. Okay, now here interchange these two, volume and molecular weight. Now P, the molecular weight, which is equal to weight by volume, and RT. Okay, and what is this one? Nothing but mass by volume. Weight is nothing but mass, and V is nothing but volume. So weight by volume gives you density. Now replace this term with D, density. P into molecular weight is equal to dRT. Now what is the formula for your density now? D is equal to P into molecular weight divided by RT. This is the formula for the density to calculate such type of a problems. What is P? It is 0.82 atm. And what is molecular weight? It is 4 grams mole inverse divided by R. What is R? 0.082 liter atm mole inverse Kelvin inverse into temperature 300 K. Now cut off all the possible units. What you will get? Here atm, and this mole inverse, this. Now here this point and this point. Here you will get this 0 and here 1 0 cut off, and what you will get? You will be remaining with 4 grams. That's it, 4 grams it is 4 by 30 and you left with liters. So 4 by 30 means it will be 3. Yeah, it is 0.133 grams per liter or 1.33 into 10 power minus 1 grams liter inverse. Whatever it may be, depending upon the option given, you can simplify this one. Okay.